Hello folks, welcome everybody. So today we are going to talk about crafting a cloud development environment with Eclipse Che and Personal AI Assistant. My name is Ilya, I'm software engineer at Red Hat. I actually work in developer tools organization. I'm also Eclipse Che project lead and I'm maintainer of workspacesopenShift.com.
Hi everyone, my name is Manuel Hahn. I'm a specialist solution architect. Sorry, I still need to switch to English. For Red Hat, and they're responsible for everything regarding modern software engineering and AI for the German public sector.
So first of all, let's talk in general what are the cloud development environments, or CDEs. So basically it's pre-configured development environment that is running in the cloud. So it's designed to be on-demand, accessible from anywhere, and equipped with all required dependencies and tools for instant development. And let's talk why cloud development environments are gaining popularity nowadays. So first of all, cloud itself is spreading and becoming more and more affordable. So there is a pretty big competition between cloud providers. And pretty much all the big companies are, one way or another, are in the cloud, no matter if it is like public cloud, private cloud, or hybrid cloud. Second is that low latency networking is becoming also more and more available, and this is actually crucial for cloud development environments, because with poor networking, that would be a pretty much poor user experience. Also, our code bases are becoming bigger and bigger, and also some big tech companies are using mono repos. And if you think about it, our laptops are not ideally suited to this very large code bases and mono repos. Because if you think about it, what was development, let's say 15 years ago, it was a completely different story. So let's take an example of Java, and if it was Java, you had one version of JVM, one version of the application server, and you was pretty much good. But now the complexity of the application changed dramatically, and our laptops are not ideally suited for that. So you need more CPU, more memory. Now you need GPUs. If you will see that in our session. So it's not ideal fit. The complexity changed dramatically. Also, developer productivity is what companies are looking for right now. And it's not exaggeration that sometimes for pretty complex applications, it takes weeks for developers to run the builds on their machine. And cloud development environments are actually fixing it really nicely. And also, another concern is privacy, code leaks. At very least, when you're running in the cloud, it provides you additional layer of security, because you can have like telemetry, logging, you can perform some audits, so it's more centralized, and you have full control of the infrastructure. So now let's talk a little bit about Eclipse Che. So it's one of the offerings on the market that provides like cloud development environments. So Eclipse Che is an open source project under Eclipse public license, and it's actually a platform for providing Kubernetes-based cloud development environments for enterprise team. So how we are doing this? Actually, we fall back on a devfile, which is an open standard for defining containerized development environment. If you think about it, the idea is similar to the Jenkins file. So in the Jenkins file, you explicitly define the pipelines with various stages, and then Jenkins understands this file and create your CI pipelines accordingly. So pretty much the same idea, but for your containerized development environment. So you have it defined in the YAML file, and then it's pretty much tools agnostic. So projects like Eclipse Che can leverage the dev file and create the containerized development environments accordingly. So let's take a quick look at how it looks like. So it's pretty simple dev file. So first of all, We specify the image, so development image with all the dependencies needed for your development. You have full control over required resources like memory limits, CPU limits, GPU limits. You can provide endpoints to expose application for testing and collaboration. Also, you can provide the volume mounts for persisting your Maven, NPM, Python repositories across workspace restarts so that download would not happen every single restart. And you can provide the shortcuts for your favorite commands to execute some, build task, run task, test task almost instantly. So now I'm going to quickly show you how it looks like. So when we talk about cloud development environments, one of the pitch is actually instant onboarding. So here I have a GitHub repository, and in GitHub repository I can have like a batch in the README file, and actually it's a link to my Eclipse Che instance hosted on the cluster. And once I click the link, my cloud development environments is going to be created. Actually, because I have the dev file in the root of the repository that defines everything I need for the development. So under the hood, Eclipse Che processes dev file and create the dev workspace custom resource object, which is basically a Kubernetes representation of cloud development environment. But now I have my VS Code running. So let me zoom in a bit. And as I said, in the dev file, I define some commands so I can quickly start my development environment. And it's going to actually start the application. So even though it might look like it's pretty simple application, but actually it consists of two containers. So in one we have like Quarkus application, in another one we have the database. So I can, for example, open in the meantime a terminal in the database container. And connect to my Postgres database. So I can connect to the food.
One needs to say he's today using the German keyboard layout for the very first time, so everything is entirely different. So
true, but I'm getting used
very
to
good.
it.
Yeah.
And actually, I can open my application. So I expose the endpoint in the simple browser. So here we can see the application, and it's actually a food database where we can add something, add some entry. So first of all, we can take a look in the Postgres that, so let me zoom in a bit. So I can I can actually run SQL queries. So here I can see a few tables. So actually I can add something on the fly. So OCX, add some entry, add item, and I will see that if I run the query again, the newly created record is added to the database. So pretty cool. I just clicked one link, got my environment provisioned, and start coding instantly. So I can do the debugging and many more things inside this cloud development environment. So I believe you got the gist what Eclipse Che is doing. And now I'm going to pass it over to Manuel, who's going to talk about like personal AI assistant and how we can even more enhance our cloud development environment.
Perfect. Thanks, Ilya. And also perhaps from my experience from the German public sector, it's that another advantage using CDIs is that CDEs is that they typically have on-prem everything. So using cloud, yes, but for certain things, the default case is on-prem and then air-gapped also. And there are really nice ways of making this happen also in that specific case where people are demanding this a lot currently. Okay. The talk is about CDEs with personal AI assistants. So how can you add some AI help, let's say, in your coding efforts? And for that, I think I don't need to say much about personal AI assistants, AI coding assistants. It's a hype since a year approximately, and I guess everyone has heard about them. Perhaps to summarize, you can generate code with it, obviously. You can let you explain the code and ask questions like where's an error and things like that. You can format it, you can write it, let it write test cases. You can ask it to write documentation and also translate from one programming language into the other one. And when my customer basically came and said, okay, we also would like to use that in an on-prem air-gapped environment. What do you say? Okay, OpenAI, which were the first, are obviously not capable of offering something on-prem and air-gapped. So we started looking for something else. And very soon, something approached to us. It's a Continue extension, which is, they claim the leading open source AI coding assistant. I haven't seen much better and much else yet. They offer an extension for VS Code and recently also for JetBrains. Please have a look. They're also really open to feedback. And I think they are still in a 0.0 version, but they are also, deploying a lot and desiring also feedback from customers. Without further ado, I will just show it instead of explaining what it does. I opened here another workspace, something I prepared, and here you see at the bottom left, can you read it properly? Yes. At the bottom left, you can see here the symbol, that's a Continue extension. And you have some free trials included when you just install it, VS Code locally, or in my case, then on Eclipse Che in my case, an OpenShift cluster, but of course you can also use OKD for that. So, and here I entered a model GPT-4 from OpenAI with my personal API key and ask it, whatever, perhaps something clever than hello, just to make a connection, and write a hello world in Fortran, which you use usually every day. You get it, you get some explanations how to run it and so on. I think everyone has seen that already. Just to show you some capabilities, we will just create a new file, add two numbers. Let's go to Python in that case. And by just making a command function that adds two numbers, it also already offers me things. Define a function, return x plus y would do the job, it's okay. When we go now to continue, I create a new session, and I give it a bit of context using the @ symbol, saying, okay, files, the current file, and I say write function, or write this function. And I get this function with nice documentation, and can just add it here, insert at cursor, and I have my I have everything I need regarding return num AI. I can just execute it and exactly run for it. I can also ask write tests. Certainly, it uses unit test framework, which is also all right. I say, okay, I will just insert it here. Import unit test, has some test cases, and executes it. It just omits this case. I don't know why, perhaps I did something wrong. Just calling it now. It's very ugly, but it works. I go to the terminal and can say, okay, run this. Okay, I have some indent error. Where am I? Okay, it somehow cut the content. Doesn't matter, we don't need too many cases. I will just go for that. Run 3 tests. I don't want to go into detail with that. Everyone knows most probably there are millions of videos out there what you can do with it. It of course depends on the capabilities of the AI assistant. Here in that case continue, and there's a lot you can add context in multiple ways. And of course it depends on the model what you are using, how capable it is for the programming language that you want to take. I just want to show you some cases how you could use it. And I don't know, I have worked with it already for years, especially with Eclipse Che, and I don't see or I don't feel any difference between something which is running in an OpenShift cluster here or locally. So for me, it's, from performance point of view, it's the same. All right. We are working with large language models, even though we perhaps I don't know, most probably we know, but using AI coding assistant is using a large language model, and perhaps we should talk about where are they coming from. Do I need to also think about the underlying model that I'm using, especially for productive purposes? When locating those models, LLMs, large language models in the AI jungle, we have the predictive AI, which people know from the past years. It's when you want to predict or forecast outcomes based on historical data. You take a model with a moderate amount of data, you build this model from scratch, and with that you can do things like somehow identifying cars on a picture with a certain probability. You can go and assess the severance of car accidents. Here it has 88%, most probably because the wheel still can be used. But those is a typical use case for predictive AI. Then the new hype, let's say, since 1-2 years is generative AI, where you can generate new original content based off trained data. You can let it write texts, let it create some music for you, or pictures, whatever. And these use foundation models, which are trained on a massive amount of data. I think it was 64 terabyte for some GPT-3 thing, only textual data. So it's really huge amounts of data, and you need hundreds or thousands of GPUs to actually train such a model, which is why not many people do it. It's only the big ones like Facebook, Google, and co. And large language models are foundation models for natural language processing. Here's an example to create a summary from a long winded email into something which is more, let's say, more concise. A typical use case is also sentiment analysis. In the first case, the person was calm, assertive, and cooperative. In the second case, he was assertive and frustrated to make decisions based on that. Just to give you an example of where this comes from. Okay, now we need such an LLM, what to consider. Yeah, the data set, what is the quality, which data has been taken, what about the licensing, is it permissive, what about IP identification? Yeah? There are companies who protect you against third-party rights, yeah? On the model, but also on the trained data. There was a Books 3 scandal, which almost every large language model used, so it's a data set which contained pirate copies of books. Okay, what do you do afterwards? So it's really important that you know where your data is coming from. And one example is VStack, which has 6 terabyte of permissive code data, which can be used to train a model for code generation tasks. And they basically went to GitHub, took a look at which extension I like, so for the programming languages they wanted to assess, then took a look at which permissive data we have, and from there they got some 6 terabyte of data, which you can now use for training your model on your own. Deployment options, yeah, online only, then you can go with OpenAI. I also do that regularly for textual things, but as my customers, they want to have it on-prem and air-gapped in almost all cases, then this is no option. Which resource needs you have? RAM, storage, CPU, GPU. You want a GPU for those tasks. It takes you from, let's say, just a number, 10 seconds to below 1 second for one answer, and this is what users also need. And of course much more. And when you read all this, it also becomes clear that perhaps you want to go with an open large language model, and there are open models available. First advantage is you have transparency, so you have no black box, you know which data has been used for training, and you have the community-driven development. You have the control, so some stability and consistency through deliberate LLM changes. When you go to OpenAI with ChatGPT, you don't know when something has been changed on the model or on the data. And since it is also not deterministic, so the answers are not deterministic, it's anyhow difficult to really spot a difference. And when it's your own model, you can say, okay, now I do a change, and then you know what has been changed. And flexibility, of course, on-prem, in the cloud. You have customizations like fine-tuning, and you are not relying on one single provider. Okay, I will just demo this also, how you can set up something like that in an easy way, how you can do that then at home or even with your mobiles. Ilya will also tell you in a second. Let me quickly start from scratch. We are here in Eclipse Che, that's a dashboard. And here you can go to create workspace, and you have multiple examples here given. There's a ready-made tile for you, Oyama, which you can just click, and then everything is being set up for you. Let's say it like that. So this is running in my OpenShift cluster, but of course you can also test it out. Ilya will say how in a second. It's doing a lot of things in the background, storage ready, network ready, it's pulling images, and what exactly is being done is defined in a dev file. This is the repo which it's pointing to, and here is a dev file included. And Ilya also already explained a bit the structure. It's YAML. You have here one project which is being checked out, CDI Oyama continue with the main branch. Then you have two components. One is UDI, that's Universal Developer Image. That's kind of a Swiss Army knife developer container image, which has almost all the tools you need on the terminal available already, ready to use. And then as a second container, you have the Oyama container taken from Docker.io. And Oyama is basically an interface to a lot of models which you can then easily use, easily consume. It's kind of a framework for running those. And here, additionally, I have some resource limits and requests for CPU and memory. If you are in an environment where you have worker nodes which have GPU, and some which have CPU only, then you can also define here, run it on a GPU. In my case, it's not needed because I only have a GPU worker node. Then you have some commands. Let me see. No, that's the old one. That's a new one. Yes, it's already up, but the continue extension is not being installed. So in total, it takes, I would say, 2 minutes or so. We let it run. We go for the last two sections, which is commands. I have a command for pull the model, Oyama pull Yama 3 with 8 billion parameters. I have a starcoder 2 model for the auto-completion, and I want to copy some configuration which is needed for the extension to set up some API keys to tell it what exactly to use. And then in the events, in the post start, I say, okay, after the workspace is up and running, pull the model, pull the autocomplete model, and configure the extension so that everything is ready to use. So you have never worked with that, and after 2 minutes, you have that. Yes, I will move it somewhere to the right side. And this is what you actually basically saw before. Only now it's not GPT-4, it says on-prem Yama 3B. And again, here I can say something clever like hello. And it also answer which model are you. It should say something about Yama, that's right. And this is not now talking to OpenAI, to some servers anywhere. It's in the same cluster talking to another container. And you can also take a look at it. Here is the OpenShift console, and we can go to the respective pods. You have one pod per workspace. In my case, I have then 3 containers inside. This is the newest one, 1621. And here see at the bottom, okay, there are 3 containers, UDI, Oyama, and Che Gateway. You can now go to the terminal into Oyama and say Oyama list, for example. And you can also have a look at the logs to be sure that it really talks to me. I will mark resume stream and show new lines. Okay, I will just mark it and say something again, hello. And then we should see another line approaching here, the post request, which has been, let's say, processed, and then a return has been sent. So we are entirely in the cluster, not leaving it at all. And yes, with that, you can, of course, then start doing customizing the model, fine-tuning it, working with RAG, retrieval augmented generation, where you actually adapt the prompt with additional data, or things like the lab method, large-scale alignment of chatbots, where you give it a file, question answers, and then it's being retrained with that approach. So there are multiple approaches, and all those you can use. Then you have the full freedom with the models that you are using, and everything is inside your own cluster, not leaving anything. Yes, looking at the watch, I will quickly show you one more thing. Which is, of course, a killer feature when I go to the terminal and say, okay, I now want to open a terminal in the Oyama. I have the GPU available, yeah, and that's currently using an NVIDIA L4. And so your developers will have access to a GPU, perhaps a shared GPU, and can then run their workloads also with their cloud development environment with a personal AI assistant. Okay, with that, I hand over to Ilya.
Yeah, thanks, Manuel. So how to get started? Actually, together with Manuel, we wrote an article. It's actually a step-by-step learning path, a guidance for pretty much what Manuel shown to you. So you can do this exercise at home. It should be pretty not time consuming. So I think within a 30 minutes you can pretty much do what was deemed during the session. Important note, so on the cluster that we provision for free, so there are no GPU nodes available, so it's CPU, so it wouldn't be that blazingly fast, but you would get the idea, so that you can have your personal AI assistant in emulated on-premises environment. So in general about Eclipse Che, so please visit Eclipse Che website. There you can find all the details and how to get started. In the getting started samples, we also have Oyama. If you are more interested in devfile, you can go to devfile.io, so it's part of the CNCF landscape. There you can find also the registry with popular dev files. So you can find various technologies there, and Oyama is also available, so you can get more idea like how it works under the hood. Yeah, and the last but not least, check out this learning path step-by-step tutorial to better understand how it all works. And with that, I believe we have a few minutes for questions.
So perhaps one thing, there's also a link that you can press, and you can actually launch the Oyama package inside your a demo cluster, that perhaps one can also say.
Yeah, you mean like this one?
Okay, you have done last.
Yeah, I duplicated on the last slide as well, so you can scan it and you can get this like step-by-step tutorial.
Perfect. Are there any questions? Or ideas? Comments?
So is Che really using VS Code, or do you use Thea?
No, we use VS Code.
You use VS Code?
Yeah, open source version.
Can you switch it out if you wanted to?
Sorry?
Can you like use Thea as well?
Yeah, I mean at some point in the past we had like TIA as the default editor, but then we decided to switch to open source version of VS Code because it was like just better aligned for our needs and for like customer needs. And so technically it's possible to run TIA, and it's open for community for contributions. So if you are interested, reach out to us on Slack, on Cloud DevTools Slack, open an issue, and we actually need community to kick in to support TIA, because like we had the prototype, but at some point in the past no one would like to support it. So we decided just to put all the effort into VS Code.
Okay, and so the second question regarding to how Che does the container running in the background. So you have some containers running for the IDE, and like in this case, Oyama. You mentioned the UDI image, which has all the commands in it. Mm-hmm. What happens if I start a server, like I'm developing a web application, I want to start running my server, I want to start running my database, I want to like all of those things. How do you make sure that those containers cannot interfere with anything else running in the same Kubernetes cluster or in the same node?
I mean, it's a general thing how you organize it. In that case, you also don't want every developer to have his or her own large language model inside the container. So you would provide one of those large language models, let's say, for 10 developers. And this is really up to you how you want to structure it. Many customers say, okay, we have, for example, a database. I have an in-memory database for developing, testing until I commit and push my code. Then it goes into this outer loop where something is being built, and there perhaps you go against, for example, a Postgres which is persistent and available for everyone, readable, available for everyone. Separation you get by namespaces, for example, by processes. So this is really, I have seen many implementations of that, but I don't see any restrictions. It's rather that you have really a lot of possibilities, and you need to see how you want to have it, how you organize your development process and development team.
Okay, and how do you deal with people having direct access to graphics cards? Usually they're harder to virtualize.
No, actually not. Okay, I need to see. Okay, I'm working at Red Hat, therefore we have OpenShift. I need to make some. No, it's not an advertisement, but I know that it was at least kind of hard to get the NVIDIA GPU operator running inside, let's say, vanilla Kubernetes. With OpenShift, you install it as an operator, and it's working. If you do that, it takes 2 minutes, and they have everything included. And a lot of stuff happened also in the last year, I would say. So there are multiple options available for virtualizing your GPUs, for GPU sharing. You don't want to give every developer one entire GPU. You can do this with MIC, for example, for NVIDIA 1/7. You can give to every developer, or you can entirely use vGPUs. So there are options available which you can then use depending on the graphics card you have, and then you can share. What I showed you in the dev file, you say NVIDIA GPU 1, which means 1 unit. If you shared it with vGPUs, for example, 1/10, then it's really 1/10 is 1. Yeah? So you can take 2, then you have 2/10 of a GPU available for your work. Answer this your question? Okay, perfect.
Which repository do you use to keep extensions? Because obviously you cannot access Visual Studio Code Marketplace, yes? Mm-hmm. No. So, and then is it your own registry? And if you own, how you feel it? And so.
Yeah, like for Eclipse Che, we're using OpenVS6. So for upstream. For downstream, we have so it's possible not to use OpenVS6, but there is like a upstream repository. It's called Che plugin registry. It's kind of a opinionated version of OpenVS6 where you can manipulate with the extensions, so you can add your own extensions. But that's a great question, because I think that what would be ideal is that OpenVS6 itself should provide a better way for running it on-prem as well, so that you can host it on your own Kubernetes cluster. yeah, so I think that would be nice to invest into. In general.
OpenV6 can do it.
Yeah, but like there are some limitations, you know. So like for example, there is only GitHub OS provider supported, and so it can do it definitely. But I think there are no documentation for doing that. I know that some customers are you know, patching OpenVSX, so they don't use OpenVSX, so they just fork it and like update it for their needs. I believe it would be nice if we can contribute as a community to OpenVSX itself and have like properly supported, documented on-prem version of OpenVSX so that you can host on any Kubernetes cluster and you can manipulate with the extensions, have the curated list. So there are, you know, a lot of opportunity to collaborate on that.
Okay, yeah, thanks.
Then thanks. I think time is already over. Thanks a lot. And if you have any questions, we are still around. No?
Yeah, thank you.